In 2013, Guy Edward Blelloch, Laxman Dhulipala, and Julian Shun began to design parallel algorithms to run less expensive shared memory multiprocessors in order to examine very large graphs.
These graphs can be very large. They can contain up to billions of vertices and edges, and therefore we need an efficient, scalable, and simple way to analyze these graphs to derive useful information from their structure.
The main difference of a parallel algorithm from what's traditionally called a sequential algorithm is there's lots of computing devices working at the same time, as opposed to just one step at a time.
So we've shown that we can actually design simple and efficient algorithms for a wide class of graph problems, most of which are actually very useful and interesting in practice.
Using their innovative algorithms, they created a series of frameworks that made it much easier for programmers to solve a wide variety of graph problems. Ligra made it possible for users to map over vertices and edges that are naturally parallel and used to describe graph algorithms. GBBS, the graph-based benchmark suite, increased implementation speeds and reduced costs on graphs with hundreds of billions of edges. And Aspen, a graph streaming system, modeled graphs that could change in real time.
The key idea behind Aspen is the design of a new compressed, fully functional tree data structure, which we use to represent the graph. And this data structure allows us to create lightweight snapshots that the queries can work on while the updates are happening.
The theoretical work of Guy Edward Blelloch, Laxman Dhulipala, and Julian Shun has revolutionized large-scale graph processing on shared memory machines and become widely used throughout the academic and industry communities.